In section 4.2, we're going to talk about how we can prove lines parallel. In our last video, we talked about different parallel angle pair relationships like same side interior, alternate interior angles, corresponding angles, and alternate exterior angles. So for example, let's look at the corresponding angle theorem. In that diagram, if lines L and M are parallel, that's the symbol that you would see for parallel lines. And remember, you'd also see those kind of like red arrows there. Then I could say that angle 2 is congruent to angle 6 because they're corresponding angles. What's important to note here is that the converse also holds true. So notice how we have a conditional statement there, or an if-then statement. If I switch the hypothesis and conclusion and say if angle 2 is congruent to angle 6, then I can conclude that lines L and M are parallel. So if I can show that one of those parallel angle pairs are like congruent or supplementary, then I could go the other way and say that those lines are parallel. So in example number 1, I'm looking at this diagram and I want to know which lines are parallel if angle 1 is congruent to angle 2. So I'm going to highlight angle 1 and angle 2, and I would see that those would be corresponding angles if A and B are parallel. So I have corresponding angles, and I would say that if those are congruent, then line A is parallel to line B. And this works for any parallel line angle pair. So in example number 2, I look at this diagram, I see that those two angles in the red are marked congruent, and I want to know now which lines are parallel. I see here CG is my transversal line, and I have alternate interior angles. So I would say that line BC is parallel to EG because I have alternate interior angles. In example number 3, we're kind of doing the same idea, but now working with an algebra equation. Determine the value of x for which line L is parallel to line M. So if L and M are parallel, I'm looking here and I see that these would be alternate exterior angles. If we have parallel lines, then these would need to be congruent. So I'm going to set these expressions equal to each other. So I'm going to set 2x plus 26 equal to 3x minus 33. And now I'm just going to solve for x. So I'm going to add 33 to both sides to get my numbers together. Then I'm going to subtract 2x to both sides to get my x's together. And I'm left with x needing to equal 59. Finally, let's end today's video with the proof. I'm given that lines M and N are parallel, and I want to prove that angle 5 is congruent to angle 4. So I might look at this here and say, oh, those are alternate interior angles. I'm going to act like I don't know that theorem, so I'm trying to prove the alternate interior angle theorem. Sometimes these can get a little bit tricky, so if you ever see any of these proofs, especially as we first start these out, I'm going to give you either all the reasons or all of the statements. So here I have all the statements filled in. We just need to fill in the reasons. So we start here, M is parallel to N with transversal P. We always start with our given statement, so that one's easy. Now, in my next statement, I'm saying angle 1 is congruent to angle 4. Now I'm going to look at that diagram, and I see that those are vertical angles, so I can say they're congruent by the vertical angle theorem. Next, I say that angle 1 is congruent to angle 5. Looking at those, I see that those are corresponding angles, so I can use my new theorem here, the corresponding angle theorem. Finally, I'm saying that angle 5 is congruent to angle 4, which makes sense. My last line is what I'm trying to prove. I look at the two lines before, and I see that angle 4 and angle 5 are both congruent to angle 1. So if 4 is congruent to 1 and 1 is congruent to 5, I could say that 4 is congruent to 5 by the transitive property. And I'm done.